All right, guys, this is Miss Corrales, and I apologize ahead of time if you guys hear things in the background. I didn't have a chance to do this video at work, so I'm doing it at home. So you might hear my husband or my daughters or my son, but I'm gonna try to do this as quickly as possible so that it doesn't, so that you guys don't get too much at this time. Okay, so as you guys know, we've been filling out this quadrilateral family, and we started with shapes that have four sides or quadrilaterals. It doesn't mean there's any relationship. We had the kite, which we're not testing on, the trapezoid, which we're also not testing on, but they are part of the quadrilateral family, so we just kind of like made mention of them. And then we have our lovely parallelogram, which is the one that we're at this time calling the parent, right? The parent quadrilateral that we're focusing on, and it has two sets of parallel lines as well as opposite lines are parallel and congruent on both sides there. We talked about the rhombus on Friday, and now we're going to talk about the rectangle. So if you guys turn to page 7 of your notebook, you guys can see that we're going to add the rectangle, and it also has two pairs of parallel lines. Remember that this symbol here is parallel lines. And so opposite lines are parallel as well as opposite lines are congruent, okay? So one thing that we wanted to make clear is that both of these shapes derive from the parallelogram, I guess you could say. That's the parent one. But these they don't hold the same properties. You have the 6 properties from the parallelogram that belong to each of them, but then the rhombus has 3 that are unique to itself, the rhombus. And now we're going to tell you guys about the 2 that are unique to the rectangle. So parallelogram has 6, the rectangle has 6 plus 2. The rhombus has the 6 from the parallelogram plus its own 3. Okay, so again, I apologize for the shakiness of the video. I'm holding it with one hand and trying to do everything else with the other. But I hope that it comes through as well, or as, clear as possible. Okay, so now I'm going to turn my notebook. And for those of you guys who were in class, we're doing this on page 11 of our notebook. We apologize to our 3rd period because we had the fire drill. Again, we didn't choose the period. It just, it was what it was. So we had to, kind of go with it. And we're hoping that this video helps them a lot more, because maybe they can stop it during the time that they're listening to it and fill out their lovely handy dandy guided notes that we have for them. Okay, so the very first 6 properties that we have here are the same ones from the parallelogram. Now, why are we doing this? Because Ms. Ramos and Ms. Corrales are very mean, and we like to torture you guys and have you guys repeat everything, okay, over and over and over. No, it's not because we're mean. I know that that's probably what you guys think, but that's not the reason, okay? The reason why is because studies show that when things are repeated, you are more likely to remember them, okay? So here we are. It says properties of a parallelogram has 2 pairs of parallel lines. You guys can kind of see where I did my own little guided notes. So has 2 pairs. Some of you guys say sets, okay? Pairs of parallel lines, and that's the symbol for parallel. Okay, opposite sides are congruent, as well as opposite angles. They are also congruent. Now this one is in the form of a question. How many pairs of consecutive interior angles or same side interior angles do we have, right? We have 4. And in case you guys were wondering, we can go down here, right into our lovely rectangle. These 2 add up to 180. These 2 add up to 180. These 2 add up to 180. And these 2 add up to 180, okay? Those are just straight out properties of a parallelogram, and they still apply here. Okay, diagonals do what? In any parallelogram, they bisect each other. That means that they cut each other in half, okay? number 6, diagonals create alternate interior angles. Now we have a couple of people that are saying it's the Z thing, right? Yes, it is the Z thing, but it's not called the Z thing. I wish that we could rename it and then you guys would all be on top of it, right? But this Z thing that we're talking about is the alternate interior angle. So I'm gonna write it right here next to it, okay? Because if you can see a Z in your parallelogram, the points are basically always going to be congruent. They are alternate interior angles, okay? So I hope that helps. Now, these 6 properties are part of any parallelogram. Now this that we're talking about today is the rectangle. Okay, so I'm gonna take my highlighter and I'm going to highlight where it says properties of a rectangle. Remember, these 2 properties, because you see 2 boxes, are specific to the rectangle. So these do not apply to a rhombus, okay? Just like the ones for the rhombus that we actually had 3. And I'll actually try to flip back real quick to those. These 3, right? The rhombus has the 6 of a parallelogram and these 3. But these 3 are unique to the rhombus. So we're not gonna do anything with those today or right now, right? Those have, now we're focusing on the rectangle. Now, rectangle, what do we see here? These little boxes. Rectangles have 90-degree angles, 90-degree angles, okay? So we can see the 90-degree angles represented by these boxes on the rectangle, okay? So it has 90-degree angles on every corner. And how many? 1, 2, 3, 4. It's a quadrilateral, so it has 4 corners, 4 90-degree angles. Okay, pretty simple, right? Okay, now let's go over to this next one. It says a rectangle has congruent diagonals. Congruent diagonals. Now, this is something new. We haven't seen this yet in parallelogram or in the rhombus. It has congruent diagonals. Now look at this. Look at what it actually says. GJ is congruent to HK. Okay, that means that the distance from G to J is the exact same distance from H to K. That's something new, right, for the rectangle. So it can be very, very helpful. You know how we, with the rhombus on the sides, they were all congruent and we kept saying, and you get a 4, and you get a 4, and you get a 4, because all the sides were the exact same length. Now we're talking about the diagonals, and the diagonals are all going to be the exact same measurement. So if this one is X value, then that would be X, and that would be X, and that would be X, right? If this was 5, then this is 5, and this is 5, and this is 5. Makes it pretty easy. I think a rectangle is pretty easy. Okay, now let's go ahead and go down here. Okay, so it says angle ABCD is a rectangle. Find the length of these 4 things. Now, one thing that Ms. Ramos and I were talking about earlier was that sometimes you guys get so caught up in being able to read this that you guys forget about what you're doing, or that you forget about things that you know. So as a best practice, I guess we could say, or a good idea of how to start these problems when you have these figures, is to go ahead and cover up this other stuff that at this time you don't want to see. All that you want to see is this, okay? And we're going to try to figure out all this stuff that we know based on these 2 new rules and these 6 rules that we already knew about the parallelogram, okay? So if we look down here, I'm going to say, okay, well, what is the very first thing I know? It has opposite sides that are congruent. Okay, so let me see. I'm going to start at the top, and I have 12 inches here on top. So I know that if this is 12 inches, this down here is going to be 12 inches, right? Because opposite sides are congruent. So this is going to be 12 inches. Okay, that seems pretty easy, right, Miss Corrales? But you know, I know it's gonna get harder. You're just playing games with my emotions right now, and you want me to think that this is easy, but you're really trying to trick me. No, it's not like that, okay? So let's see, what about this 5 over here? 5 inches. Well, that still applies. Opposite is gonna be congruent. So over here, so it's CD, I'm gonna go ahead and put a 5 inches. And I'm sorry I'm not gonna write the inches because I can't seem to do this with only one hand. Oh, there, I got it, but it looks like a kindergartner wrote it, okay? My apologies. All right, so now I got these 2 sides and I got these 2 sides, and what do I do with the 6.5? Well, just in case we were a little confused, this 6.5 belongs to this piece of the diagonal right there, okay? Oh, well, Miss Corrales, I just remember up here you were talking about these are congruent, right? This line and this line are both congruent. And as well as you were just saying that diagonals create, or diagonals bisect each other. So that means that this piece is also the same length. And that means it's 6.5. Okay, and what about this piece? Oh, rectangle, right. This is a rectangle. That means that all of them are going to be the same. And you get a 6.5. And you get a 6.5. Okay, so those are all 6.5s. Okay, there's nothing else that I can do except that if I wanted to mark my 90-degree angles, which I can, but they're not going to be pertinent to this exact problem. But let's go ahead and mark it just because we know that this is a rectangle. Okay. All right, so now let's go down here, and we have an angle that is 61. We have angle 1, 2, 3, 4, and 5 that are missing, and I apologize. You guys probably hear my 2-year-old in the background crying. She just woke up from a nap. I'm gonna see if my husband went to see if he can tame that little beast. All right, so what do we know about the corners? Look, we just did something up here. Those are 90-degree angles, right? Okay, so I can do 90-degree angle symbols here because it's still a rectangle. So I'm gonna go ahead and do that. Okay. Now I'm sorry that they're uneven, but okay. So 5 is 90, 3 is 90, 1 and 2 combined are 90, and 61 and 4 combined are 90. Okay, so now let me think. Is Ms. Corrales trying to trick me with something? No, she's not, because she seems pretty nice sometimes in class, right? Okay, so if she's telling me that this corner is 90, but this piece is 61, what do I do to get 4? Right? Let's see. Maybe I can just subtract, right? So if I have 90 and I subtract 61, which is this piece that I already know, what do I get? I get 29. So does 29 and 61 equal 90 together? Yes, they do. What is that thing that Ms. Ramos and Ms. Corrales keep saying? They are pew, 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 right? What is this? Complementary, okay? So complementary angles. All right, so now, Ms. Corrales seems to like this little Z here. What is she talking about? Alternate interior angles. And I know that alternate interior angles are congruent. So let me see. Can I draw a Z here? Yeah, I can. Look. That means that this 61 is going to go over here. Let me try to open one of these markers. So that is alternate interior to this too, 61 degrees. And if this is 29, how big is 1? Or what is the measurement? It's going to be 29 degrees as well. Okay, so I know all these angles. I think I'm pretty good. All right, now let's go see what we needed to do over here. All right, so it's actually asking us for BD. Okay, let's go over here and we have BD. Oh, it's a diagonal. Okay, so if this is 6.5 and this is 6.5, what should I do? I add them together, okay? So 6.5 plus 6.5 is 13, and we're talking about inches, okay? So this is 13 inches. Now we're looking at CD. Oh, look, Miss Corrales was like, Miss Corrales might be trying to trick me, you know, but no, she's not. Opposite sides are congruent, so CD is 5 inches. Okay, what about AC? Let's see, AC, that's that whole thing, right? And one of the new rules from rectangles is that rectangles have congruent diagonals. But I can do the math. 6.5 plus 6.5 is 13, just like it was up there. Okay, AE. AE, that's only half. And I know they're all congruent because of those little orange marks, so AE is 6.5. Pretty easy, right? Okay, so now we have this down here. It's just asking us for all the angle measures that we have. So we can write them all down. Measure of angle 1, measure of angle 2, measure of angle 3, measure of angle 4. But you know what? Let's be a little lazy like Miss Corrales and Miss Ramos, and we're just going to say that the measure of angle 3 is congruent to the measure of angle 5. And they are both what? They are both 90-degree angles. And the measure of angle 1 is congruent to the measure of angle 4, and they are both 29-degree angles. And last but not least, we have the measure of angle 2, and that is 61 degrees. Okay, it's pretty easy. So now what is up with these empty boxes, right? So these boxes are here to remind us that we still, besides the rules, we still need to see other things. And one of the things that we still need to see in these images, and this one helps a lot right here, is that we have 90-degree right triangles, I mean. Okay, so when we have right triangles, we're able to solve for problems, right, such as here, that we're looking for sides or angle or side measurements, using the Pythagorean theorem. So we're gonna go ahead and just take a snippet, right? We're just taking this bottom piece, and I know it's not drawn exactly, okay, but be nice to me. I'm trying to do this with one hand. ADC, and it's a 90-degree angle. And what is it that we usually use for 90-degree angles? 90-degree triangles, we use what's called Pythagorean theorem. We have two legs and a hypotenuse. Now, in this case, when we're talking about the hypotenuse, look, I did it orange because we're actually talking about the diagonal. That's what would be the hypotenuse, our C. Okay, it doesn't matter which one's A or B because we're gonna square it and add addition is commutative. Okay, so just make sure that you do A squared plus B squared equals C squared, and C is the one that you need to make sure that you don't mix, okay? And that's Pythagorean theorem. What's the other thing that Ms. Corrales and Ms. Ramos don't want us to forget that exists is these isosceles triangles right here, right? This is an isosceles triangle. This is an isosceles triangle. This is an isosceles triangle. And this is an isosceles triangle. Okay, we can't forget that those are there because that can make our lives so much easier instead of trying to figure out 101 other things, okay? So let's go ahead and just take one of them. And if we have this angle measure here, that would be like, say, 29 degrees. This would be 29 degrees. Okay, and then this one would be different. Okay, so we know that rectangles also have 4 isosceles triangles. And let me just make these. Oh, you can't really tell that those are blue. Okay, I just tried to make them a different color, but that didn't work so well because I wasn't paying attention to my colors. Okay, so that's practically all that we want you guys to know in terms of this. Okay, I hope that it helps you guys. I hope third period that you guys get a chance to see this. And if they didn't, and if you guys know someone in our third period, maybe, you know, just send them a picture of your notes, maybe try to explain to them what's going on, okay? Oh yeah, so you guys have homework tonight, and the homework sheet, if I can find it, here it is, okay, was not too long or too complicated. So here we have examples from the first page, and I'm gonna go ahead and work out D, because I actually had somebody ask me a question about D earlier, and I have it already here set up. I'm not gonna actually work it out for you guys. All right, so we have, you see how I highlighted and I used my colors to figure stuff out? It says AE is 9 centimeters, so I know that if AE, this piece of the diagonal, right, it's bisected, is 9 centimeters, so is this one, so is this one, and so is that one. And DC is 15, that's down here, that's his side. So the question was, how do I find AD? And I think for a second that person said they were confused as to whether they were using the rules of a rhombus or a rectangle. And I said this is a rectangle. So look at this. We can just use the information that we need. Where did I get this 18? Well, I just added 9 plus 9, right? Because it's the whole diagonal, not just one piece of it. I have 18 centimeters here, 15 centimeters here, and then I have my missing value on AD. Now, the thing that I actually didn't tell this person, because they said they had it after this point, was how do we set this up? Now, if you guys were paying attention just to like 5 minutes ago, the diagonal is always going to be C. So either A or B is missing. We can say that A is missing, right? So our setup would be x squared plus 15 squared is equal to 18 squared. Okay, so I'm gonna leave it at that for you guys. I'm not gonna solve it because I know that you guys can do it. What I am gonna do is I'm gonna tell you guys that tomorrow's DNA is coming from the back. It's actually going to be I. But since we've been noticing a couple of you guys haven't been doing the homework, that's why we've been using them, because you guys are like, I don't know what that is. We've never seen it. And I'm like, well, it was part of the homework. So now the DNA is going to be from the homework as well. And I hope that you guys can watch this. And if you guys do watch it, don't tell anybody else. So when it's DNA time, that you guys are just like, oh, I got this. And they're going to be like, how did you figure that out? And you're going to be like, well, I studied. I did my homework. I watched the little videos that Ms. Ramos and Ms. Corrales do. Okay, so we have the measure of angle BAC. BAC. That means it's this angle here. Okay, and it is 3x plus 115. And then you have the measure of angle ADC. ADC. That's this whole thing. And it is 40 minus 2x. Okay, so how am I supposed to figure this out, right? I have an angle up here, I have this down here, but I don't have a third one. How am I supposed to do like triangle sum, and add them up to 180? Well, that's the pretty cool thing, right? If you guys can extract this information, and let's see this. What kind in a rectangle, right? Because this is a rectangle. What kind of angles do we have in the corner? They're 90-degree angles. So that doesn't make a difference here. This is also a 90-degree angle. So how can we solve for x? Easy. We're going to go ahead and say that 40 minus 2x is equal to 90. This is how we're going to solve for x.